All right, so lesson 6 and the last lesson that we want you to complete in this week 2 of your stay at home and stay away from people week of school is lesson 6. So compound linear equations and inequalities. And when we see the word compound, I'm going to highlight it here, right? Compound means that we're talking about more than one. So more than one linear equation and the solutions that could work there, and more than one inequality. So it says a compound linear equation is formed when two linear equations are joined by the words and or the words or. So and or. To find the solution to a compound equation, solve each equation separately. Linear equations joined by and must have the same solution, and linear equations joined by or can have different solutions and still be true. So in order for one that has and to be true, both of those solutions must fit that set of equations. But if it says or, only one of them has to be true. So if we take a look at this first one, it says find the solution to this compound equation using set notation. So using set notation here just means that put our answers in these brackets with a comma in between them, right? Whatever x equals, we'll put in there. Fancy words, not a fancy thing. Take a look at how they went about and solved each one of these separately. So they started with the equation on the left, right? This 4x plus 4 parentheses x plus 1 is equal to negative 12. They started by using the distributive property. So multiplied 4 times x, then 4 times 1 to get 4x plus 4. Then they subtracted 4 from both sides, right? Minus 4, minus 4. 12 minus 4 is negative 16. 4 minus 4 is 0, so we're left with 4x equals negative 16. Then divide both sides by 4. Divide by 4. X is equal to negative 4. On our other side here, 3 minus x equals to negative 2. They went through and they said that we subtract 3 from both sides. Subtract 3. Negative 2 minus 3 is negative 5. So negative x equals negative 5. We can't have a negative x though, so we divide by negative 1. Divide by negative 1, and x is equal to 5. So if we take a look here, we have two solutions, right? If it says or, it means that we're looking for either of these numbers because one of these numbers would make one of these equations true. So we'd write our answer in set form as negative 4 and 5. And if we take a look, choice D matches up with that one there. All right. So choice D is the solution using set notation there. All right, then if we keep going through here. A compound inequality. So now inequalities are a little bit different because again, remember our inequality means we have a range of solutions and not necessarily just two different numbers here. So a compound inequality is formed when two inequalities are joined by the words and or. And a compound inequality can also be written as a single number sentence with two inequality signs. So examples of such inequalities and their graphs are shown below. So here we have two inequalities. So n is greater than negative 3 and n is less than 4. So one way to write this is the same way over here. We still have our n is less than or equal to, or negative 3 is less than or equal to n, which, right, is the same as n is greater than or equal to negative 3. The one way that we can tell it's the same is see how here our inequality sign is opening up towards our n and kind of pointing at our negative 3. If we switch the order of those two well, one's a number, one's a variable, and one's a number here, they still have to be facing the inequality in that same way. So the inequality still has to be pointing at negative 3. So see how here it's pointing at negative 3. And it still has to be open to n. See how here it's open to n. So we're allowed to kind of flip them back and forth as long as we flip the inequality with it here. Then we have n is less than 4. So that's still going in that same direction there. n is less than 4. Now, if we're to graph this on our number line here, we start with our first number here, which is -3. So we have -3, we have a less than or equal to sign. So we're going to fill it in here with that solid bubble. Then we go to this one here is just a less than. So at 4, we just have an open circle. And then the n is in between -3 and 4, just like in this inequality. So we shade in between that inequality there. The next one they gave us was that n is less than 2 or n is greater than or equal to 6. So again, we have n less than 2. So we circle, open circle at 2 because it's not equal to, right? And then we shade going towards 0 because we're looking for all the numbers less than 2. And if we have or here, n is greater than or equal to 6. Again, we do a closed circle at 6. And then all the numbers that are greater than. So 7 is greater than 6, so we shade going that way. Notice here how when we have our or, we have two different solution sets that are pointing out in two different directions. So if we were to pick a number, it wouldn't be true for both of them. It would only be true for one of them in this case here. So 1 is less than 2, but 1 is not greater than or equal to 6. So as we keep going along here, let's take a look at the next set of sample problems. So starting at the top, it says to find the solution to a compound inequality, solve each inequality separately. Sometimes it helps to rewrite the inequalities contain and as two separate, rewriting inequalities containing. Sometimes it helps to rewrite inequalities containing and as two separate inequalities. So we see and a lot of times it's going to be one inequality. We're going to separate it here. So when it takes a look, take a look at this first question here. It says, which graph shows the solution to 7 is less than -3 minus 2x, which is also less than 11. So here we have a compound inequality using and, right? Because we're looking for the number that fits both of these here. So we're going to do is separate them first. So we start with 7. So I'll write over on this side here. 7 is less than -3 minus 2x. That is one of our inequalities. Then over here, I'm going to write the second inequality. The second inequality, we start with what's in the middle. So -3 minus 2x is less than 11. Now we'll solve each of these independently and then combine them again. So here, first we want to get x by itself. So we're going to add 3 to both sides. 7 plus 3 is 10. We still have our less than symbol. Then we're going to -3 plus 3 is 0. So we're left with -2x. Divide by -2. Divide by -2. And we're going to get that -5. Now when we divide by a negative, remember we must flip the inequality sign. So -5 is greater than -2 divided by -2, positive x. Now looking at our other equation here, our other inequality here. We're going to start by adding 3 to both sides. That will get rid of our 3 on this side, so we'll have -2x is less than 11. Or sorry, it's less than 14, because 11 plus 3 is 14. Then we divide both sides by -2, divide by -2. So here, -2 divided by -2 is equal to x. When we divide by a negative number, we must change the inequality symbol. So instead of less than, we have greater than, and x is greater than -7. All right, so when we take a look here, we have our x is less than -5 and x is greater than -7. So what we want to do is set up our compound inequality again. So we have x in the middle. Then we know that the bigger number here is going to be on the right. So it has to be less than -5. And that's the same as this one, because remember, if we take this and we flip it so it's x at -5, we can flip our inequality and it's still pointing at that x and kind of opening up towards -5, just like we have here. And then what we're going to do is do the same thing over here, but flip this one. so that we have negative 7 is less than x here, right? Because we want our x to be in the middle with our less than negative 7. So we have our smaller number, negative 7 here. Our symbol is still facing that x, still opening up to that x, and then we have less than negative 5. So x has to be in between negative 7 and negative 5. So if we're drawing a number line here, we'd have a number line. I'm going to put, at this side we'll start at negative 4, then negative 5, negative 6, negative 7, negative 8. Starting at negative 7, we look here, this symbol here is less than, so we're going to put an open circle. Then at negative 5, we're also going to put an open circle because we have less than, we don't have an equal to. And here our x is in between, so we shade in between. So we're looking for the answer that's similar to that here. And if you take a look at choice A has an open circle at negative 7, open circle at negative 5, and shaded in between. So choice A is our correct answer. Moving on to sample 3. It says, look at the graph below. Which of these inequalities has the solution set that is shown in the graph? So again, we always start off with the number on our left. So this is in between negative 3 and negative 4. So this number here is negative 3.5. Then we know that this is going to be less than or equal to x. The reason it's less than is because that the x is in between here. Right, so the x is actually greater than negative 3.5. And we know it's equal to because that's shaded in there. Then we take a look at 1. 1 has an open circle, which means we're going to leave it with just a less than sign without the equals to. And then the number 1, which is the top of that solution there. We look for the one that has, notice how all of them have the same exact numbers, negative 3.5 and 1. So we're really just looking at the inequality symbols. So we want the first inequality symbol to be less than or equal to. So if we take a look at choice A and B, the first inequality symbol is less than or equal to. C and D, it is not. Cross it off, get rid of it. Our second inequality symbol is just less than. So now we're looking between A and B. If we look at choice B, it has the same exact inequality symbols that we used, and therefore it is correct. Because we had an open circle at 1, so just less than at 1. Closed circle at negative 3.5, so less than or equal to at negative 3.5. And that's those sample questions there. So if you take a look, some of the problems that you have to do. So here, looking for one that solves, it works for both of these equations. So you'll solve each of these equations independently and then hopefully have the same answer there, right? It's going to be one of these choices. When we take a look at this one here, it says, which graph shows the solution to the compound equation? Remember that when we showed solutions to equations on graphs with a number line, you're just going to solve this first equation first, find what x is equal to, solve this second equation, second, find what x is equal to, and both of those will be a point on this line here because we have or. So or, they can be different numbers here. So in this first choice, right, it says that x is equal to either negative 4 or negative 1, right? So they're saying one of the equations might give you negative 4 and the other one gave you negative 1, and that's how they're showing their answer there. When we take a look at the compound inequality here, that is or. So when we have or, we're going to keep them separated the whole time, right? Solve the first inequality for j, solve the second inequality for j, and see which one matches with your answers down there. Going over to question 4. Let's see where we're at. So question 4 has to do with sides of a triangle. And here we're talking about and. So you want to solve each of these inequalities separately and then kind of put them together, right? So notice how all of the ands here, right, are shaded in between. If you take a look, all of them are open circles, so they're not going to try and get you with that there, as they're saying they're both the symbols that are not equal to, so you won't be able to eliminate it that way. But once you solve each one, you should be able to find it on there. Take a look at this question here. It's a little bit more difficult, right? But we still do have two a compound inequality here using and, so we could rewrite this as 50 is less than or equal to 64 minus 0.5n, right? And you can solve that by itself. And then also solve 64 minus 0.5n is less than or equal to 60 by itself, and see which one of those helps you to answer this here. Then, taking a look at the back here, what is the solution to the inequality? Solving here, when you're solving for or, right, you're going to come up with two different solutions here. So make sure you write them out. And 7, similarly here, if you want, I recommend splitting it up into negative 13 is less than 2k minus 1. Then also 2k minus 1 is less than 5. And solving each of these independently and then combining them at the end. Or rewrite them using the word and. So good luck with those two questions there. If you have questions, make sure to send me a message on Schoology. I'll get back to you as soon as I can. Can even go through and make some videos if you're getting stuck here on certain questions, showing you some of the steps where you might be getting stuck. So make sure to reach out. All right, good luck.